Hi, this is Shanda. Welcome to day 2 of radiation. And yesterday, after I got done with radiation, a few things were quite unexpected. First off, my car wouldn't start, and that created a situation where I could have been in the parking lot for a couple of hours. But I didn't mind that one bit, and that actually got me thinking about time and how I view time. So today, I really want to talk to you about time. Now, I know that might be a little bit confusing because I started this on the premise of a radiation journey, but this really actually has nothing to do with cancer or radiation. This is really a mindset journey, and I'm using the radiation as an excuse. Cancer doesn't define me, but my positive mindset, positive outlook absolutely does. It is very much part of the core of who I am. So when we talk about time, I need to let you know that time has been something that I have thought about quite a lot. And I don't know if that really comes from conversations with my grandfather. When my grandfather was older, after my grandmother had passed away, we used to spend a lot of time talking about quantum physics. And that's not because I'm a science geek, it's because my grandfather is extremely intelligent, but he had a lot of difficulty talking about emotions. And so we had to find a common topic that we could both talk about and pass time together. And so quantum physics was something that excited both of us. Now, I had to do a lot of studying for the things that my grandfather just knew naturally. But in my studies, I, of course, came across the theory of relativity, which is something that I'm very excited about. In fact, Einstein is one of my biggest heroes. And I want to talk to you a little bit about the difference between Newtonian time and Einstein time. This is going to be very, very important to us coming up soon. But Newtonian time is the idea that time is linear. Now, if we think about that, that's how we measure our clock time. So for instance, we have 1 a.m., then 2 a.m., then 3 a.m. But if time is linear, it's also finite, at least within our lifetimes it is. So in other words, we are constantly aware that we're running out of time. That causes us to have expressions like, I'm running late, or I don't have time for that. But what Einstein figured out is that time is actually not linear, it's relative. He, in fact, identified something called the space-time continuum, or maybe it's called the time-space continuum. But let me explain that for just a second if you're not familiar with it. So the idea is that time and space are actually connected, and not only are they connected, but they're curved. Let me kind of talk to you about how Einstein came to this theory, at least the story about how he came to the theory, and it might help you understand the theory a little bit better. So Einstein used to be a records clerk, and one day when he was leaving his work, he got on the train and he saw a clock tower. And as he was going away from the clock tower, he was thinking, if this train were going the speed of light, it would be interesting because that clock tower's hands would appear to slow down or even stop the faster that I was going. Whereas the people who were standing next to the clock tower, the hands on the clock tower would be moving at the exact same speed that they'd always moved. So what Einstein realized is that the faster you're going, the slower time goes. And in fact, if you're going to the speed of light, time is so slow, it's either completely stopped or it appears to have stopped. Now, what's really, really interesting is we can actually measure this. Another thing that Einstein figured out as it relates to time and space is that the gravitational pull on things also slows things down. So the faster you're going, the slower things are, and the heavier the pull of gravity, the slower things are. So let me explain that for just a moment. If you think about the Earth, and as you get closer to the Earth, there's a larger gravitational pull. And as you're further away from the Earth, there's less of a gravitational pull. If you've got a guy falling out of a sky, right? The further away he is, the slower he's going to fall. But if he gets close to Earth, he's going to be falling a whole lot faster. Good thing for him, time's actually going to slow down. I know that sounds kind of incredible, but it really does. And that's because he's going faster, right? So the heavier the pull on gravity, the faster, the faster your velocity is, but the slower time is going to be. Now they've actually measured this, scientists have, because they've measured times up in the space station compared to time on Earth, and they've noticed that this is actually true, but it's only by like nanoseconds. We would never perceive this ourselves, but it's a really important phenomenon to understand, because if you really think about time being relative, it could potentially be manipulated, okay? Or at least from your perspective. And so a guy by the name of Gay Hendricks spent a long time thinking about this, and he realized that perspective has an impact on time, or at least your perception of time. So let me give you some examples there. If you have a person holding a bowling ball with their arms straight out, and you tell them to hold that for 5 minutes, I guarantee you that's going to be the longest 5 minutes of their life, all right? But if you have two friends chatting and you let them only chat for 5 minutes, that's going to be a quick 5 minutes. And even though by clock time, the amount of time that has passed is exactly the same, if you were to talk to each of those individuals, their experience of the time is going to be completely different. So what I want to do with you guys tomorrow is talk to you about how we can harness some of these ideas, and how we can slow time down when we want to slow it down, how we can speed it up when we want to speed it up, but most of all, how we can enjoy the time that we have and make more time to enjoy the things that make us happy. So I'll see you again tomorrow. Thanks, guys.